Okay, so once you're logged in, you can get to different platforms, but we want to actually go to another one. It's just the Jupyter Hub today is sponsored by Atom Platform, and I just wanted to say thank you again, because specifically teaching with Jupyter Hub, it's very convenient. So now I ask you to go to https://opengeohub.atomplatform.eu. And you should come to an interface that looks like mine. Any problems? Okay, good, good. And then you can sign in with the single sign-on. And you should actually now be into Jupyter Hub. So you should have the same interface. Okay, good. Okay, good. So basically, my two sessions here are here in the folder. So the first one is analysis of big Earth data, and the second one is dashboarding with Jupyter and voila. So today, this session, we enter the folder one, analysis of big Earth data, and then you see here a list of Jupyter notebooks. I got the impression from the small survey I did in the morning that it would be helpful just to give a short overview on Jupyter and Jupyter Hub interface, just to understand how you can actually work with it. And so I would start with the notebook Intro to Python and Jupyter. But before we start, so basically what I want to say is also that it follows here, the sequence of the course is the order of the notebooks. So basically, if you want to start, you should open up the index notebook, and this gives you a bit more details on the course. Again, some access to the Jupyter Hub, what I think everyone is now there. What this lecture is about, I think I gave already quite an overview this morning, and the lecture outline. And then yes?
Sorry, but how do you get from the platform page for different options to? Yes.
So please go to here, to https://opengeohub.atomplatform.eu. Is this big enough, or shall I make it a bit bigger? How is it for bigger? Okay. Better or even back a bit? Yeah? Okay, so here you have to go here, and then you should get a SSO single sign-on button, and if you're logged into the platform, then you should actually also be able to access the Jupyter Hub. Okay? Good. So before we start is also that I really see this as an interactive session, so don't apologize if you have questions. This is really an open question. We are a small group, and if there is anything you don't understand or you want to know, then please shout. We have enough time. Good. So if everyone is there, then we can go to index 00_index.ipy notebook. We go to lecture outline, and then I will start to give a short overview of Project Jupyter, why Jupyter notebooks are great, and why I think you should try it out as well. Good. So Project Jupyter, in the official documentation, it says that Project Jupyter exists to develop open source software, open standards, and services for interactive computing across dozens of programming languages. So it started mainly with Python, but now it supports more than 40 different programming languages. So this is why I also said it is set up today with Python, but it's also easy to set it up with the R kernel. And you can also in Jupyter notebooks basically combine different programming languages in one notebook. So that's really great. just to understand, who actually worked with Python before here? Okay, so half of it. Okay, good. Okay, it's not too bad. So if we talk about Jupyter, it started with Jupyter notebooks, but now it's much more. So Jupyter is not only notebooks, it is also a Jupyter Hub, which we use today. And Jupyter Hub is basically a server, which is great for teaching and learning. So because once you logged into the Jupyter Hub, this is now your environment. So you can make changes, you can add cells, you can make changes to the code, and you don't change the overall setup of the course. This is your learning environment, and that's quite good. And also on Jupyter Hub, you can, for teaching, for example, you can already set up the environment, you have all the libraries you need, and you're ready to go to teach what you want to teach, rather than installing packages and libraries for a long time. And there's also Jupyter Lab, which is, it's becoming more and more a software development environment. So this is like an installation on your local machine, but there it's similar to RStudio or Spider, where you have a really development environment for Jupyter notebooks, which makes it very convenient to develop and work with Jupyter notebooks.
When you find it so you can like program in it?
Yes, exactly. So basically it's like, so you program in Jupyter notebooks, yes. Yeah, so but at the same time, while you program, you can then also easily share it as notebooks, etc. So it makes it much more easier to combine everything, rather than having different programs for different things you want to do. Okay. Good, this is what I already said. So Jupyter Notebooks, it supports over 40 programming languages. It can be easily shared on GitHub. I think if you look on GitHub for notebooks, I think you get millions of hits. It's at the moment, it seems there is a new fashion because it's also so easy to use Jupyter Notebooks. But my credo is a bit that because it's so easy, we also going towards dev of Jupyter notebooks, because everyone is just dumping code into a Jupyter notebook and then thinks, okay, my code is reproducible because I have a Jupyter notebook. But that's not the case. So in order to be reproducible, you also have to invest a bit of effort, not only start a Jupyter notebook and share it. And but it's so there's an entire ecosystem, so you can share it on GitHub. There is NB Viewer, if you don't know it, it's here. So you can basically paste a GitHub or GitLab link here, and then you see your notebooks nicely rendered. We can actually make the example here that we actually so I just copy pasted a GitHub link for, so the index notebook for today's session. And this is how you now can share nicely rendered the Jupyter notebook with NB Viewer. But this is static, so this is not interactive. So you can, of course, the links, they work, but so you can't execute code via an NB Viewer. But still, it's nice to share your research with colleagues. Good. Installing Jupyter is very easy. So if you use Anaconda, or you can also install it with pip. So it's here's actually a Conda Jupyter notebook. You can use also pip install to use Jupyter or to install Jupyter. And once you installed it, you can run it on the terminal. You open, so you go to a folder and you run Jupyter notebook, and then your Jupyter server starts. So we can actually also showcase this. This is probably a bit too small. I actually have to just go to I should have prepared this before. I'm sorry. Just have to run my. Okay, here. Okay, so I just opened my Python environment, and then if I run Jupyter Notebooks, probably I go to a more meaningful. Okay, so now I'm in the. No. So now I'm in the folder of the content today, and now if I run Jupyter Notebook, basically a server, like a local server starts, and I have the same Jupyter Notebooks on my local machine. I close this again, and I go back to the Jupyter Hub. Good. So who worked with Jupyter Notebooks before here? Okay, a bit less than who used Python. Okay, good. So so what you already see, you're already using a Jupyter Notebook. There is like just a bit of a better understanding. So you have on the top, you have a menu and a toolbar, which lets you run cells, which provides you buttons in order to execute something. So you can run cells, you can add some cells, you can cut out cells, you can save your notebook. I think most important is that in a notebook you have different type of cells. So anything which is like a documentation, so text or like an image, this is a markdown cell. So here, for example, this cell is a markdown. If we open it, you see that you can combine Markdown and JavaScript in order to document your Jupyter Notebooks. If I want, so per default, if I open a new cell, I get a code cell. So, and you see here in this interface here, what cell type you have. So this is code. If I want to change it to Markdown, then I can just select it here, and you can enter your Markdown here. Another good, I think something important to know is that there is a difference between a active cell and a passive cell, I would say. And so if it's highlighted here in green, then your cell is active. So this means you can actually start coding. I can also make it passive. Then the color has blue, and I can't, so if I try to do something, then I can't enter something. So I really have to make the cell active, and then I can also execute it. There's some, I think with everything, there are some useful shortcuts, like for example, escape switches to the command mode. So it switches to an active or inactive cell. So if you're in an active cell and I press escape now, then the cell gets inactive. Then, yeah, like B is inserting a cell below, A is inserting a cell above, and some other useful shortcuts which you can have a look for when you start using Jupyter Notebooks. I think the nice thing with Jupyter Notebooks is also some cell magics, which makes it very easy to do different operations. So if you enter %ls_magic, then you get a list of all the magic commands that are available in Jupyter Notebooks, and there's a lot. I just listed here some which might be useful for you while you work and develop with Jupyter Notebooks, like for example to see and also to set environment variables. You can use %env. You can also, within Jupyter Notebooks, you don't have to go to the terminal. You can also install and list libraries. You can also easily write a file. So like with $% write file and then the name of the file you want. So in this example, for example, we say we want to write the file hello world.py, and then we want, in the file, we want to print, we want to add print hello world. And then it's in the file. So we should, so if we go actually here, if we here, then we see here now a file was created hello_world.py, and then we can also load the Python file here, and then it's executing or loaded, and you can see what is in there. Yeah, you can also use a counter for how long your code runs. This is, I think this was formerly, but now this is even, I think, not necessary anymore, that you get your visualizations directly in the Jupyter notebook. And but this is, I think, already standard now. As I already said, Jupyter notebooks, it's all about reproducible research, sharing your research. So you can share it with NB Viewer, you can share it on GitHub. There's also Mybinder. Binder is basically, it's similar to JupyterHub, just, or it's, I think it's similar to Dockers. So basically you can set up a Mybinder which has already all the environment available, which is needed to run and execute the notebooks, and you can share the link, and people can start the binder environment and can run the notebooks. Some more information on, if you're interested in Jupyter in general, JupyterHub, Jupyter Lab, you can have a look later. Are there any questions so far? Yeah?
So you can,
Yeah, yes, there are two ways. So there is a package, it's called Py2R, and you can basically, so you can do two things. So you can either just run your R environment. So if they are here, I just take this down. You see here, this is the kernel. And so this shows you, okay, this is a kernel based on Python 3. But you can also set up your Jupyter on AR kernel. And then your notebook is basically an R environment. So it just understands R. If we want to do this, I think it's called Polyglot Programming, where we combine different programming languages within one workflow. Then you can even, so with Py2R, you can specify for each cell which programming language the cell should understand exactly. I can't promise, but I was thinking maybe for one of the evenings that I can set up one small example how this could look like, this polyglot programming between different two examples. So I make an announcement if I manage to set up a small example. Yes? No, it's so you can do both. So if you have Conda, then I would recommend Conda Jupyter Notebook. Yeah. You don't have to execute it on JupyterHub because the environment is already there. But if you have it on your local machine, then yes, you do Conda. Yeah. Okay, good. So then I would start with the real lecture. Is there any questions so far on Jupyter notebooks? Okay, good. Then we go back to our index file, but before I think, no, I do it later. Okay, good. So now we go to, or we can even stay here and we go to the next Jupyter notebook. So as I said this morning, I will go over different data access systems, so what the data access system is about, what data you can get there, and a short example how you can retrieve data. And depending on the data access system, it's either downloading data or like interactively that we load data from the online platform and visualize it. So it just shall give you an overview of different mainly Copernicus data. Who heard about, so who is familiar with climate data and atmospheric composition data from Copernicus? Okay, not so many. Okay, good. So I hope then it will be helpful. So who heard about Copernicus climate data store? Okay, one. Okay, good. So okay, good. So so basically, with the Copernicus program has six different services, and 2 of these services are run by the European Center for Medium Range Weather Forecasts, and these are the services on climate and on atmospheric monitoring. And the climate data store, or the climate service, provides climate reanalysis data and also seasonal forecast data, what I said this morning. And the data you can access on the Copernicus Climate Data Store. And so it's a web interface where you can, so you can either browse on the web interface and then you can download their data, or if you want to, because mostly with climate data, you're interested in, it's much more than one time step, for example, then you can also use an API to download the data. And then what I said also this morning, to make it easier to develop applications based on this climate data, there is also Climate Data Store Toolbox. It has a Python interface. It is based on xarray, so it helps you to develop applications. So how this web interface looks like? So we go to cds.climate.copernicus, and you see. Is it big enough, or shall I make it bigger? Yeah. So you see here the menu, and I'm now already in data sets. You can, even if you're not logged in, you can also search the data sets, and this is all the data sets you can get. For example, we can, if you, for example, so the most popular or most prominent data set is the climate reanalysis data set. It's going back until 1979, and will even go back soon until 1950. And you have for over 130 variables, hourly data sets on a 25 kilometer spatial resolution climate data available until almost near real time. So if you look for ERA 5, then you see here different type of, not type, but different subsections of the data. So the data is provided either in hourly or monthly averaged already. So specifically for climate application, rather than downloading a long time series for hourly data, it's also quite useful sometimes just to download directly the monthly aggregated data. But there's much more data available. So like for example, there's fire danger indices available from Copernicus Emergency Service. There's also river discharge information if you have more hydrological applications. So you can really have a look there. Some very prominent or popular data set is also seasonal forecast data. And these data is either daily data up to 6 months ahead, or monthly statistics on seasonal forecast data. Just to understand, so all the data is part of Copernicus and it's openly available, but it's not like real forecast data. Yes? Seasonal forecast is global. Yes. Yes, so all the data is global. Yeah, global. 25 kilometers, and seasonal forecast data have 10 kilometers, if I'm not wrong. Yes. So ERA 5 climate reanalysis is for global, 25 kilometers for ocean and land. Then there is the ERA 5. So you see here ERA 5 land, and this is this subset. It has, I think, around 50 variables, and it's only for land, but then on a better spatial resolution with 9 kilometers. Yeah. Okay, so this is the interface. You can browse through the data sets. Let's say we interested in ERA 5 land monthly average data. You get some information, and then you get here like, information how you can download data. This is the web interface, what I just said, or also general documentation. So if we go to download data, here you can select the data you're interested in, like monthly average reanalysis, then 2-meter temperature, for example. You can also select multiple variables and retrieve multiple variables at once. And then, so this is all the variables. We can select a year, a month, time. And then here you can even say you want to have the whole region, or you can also you can also subset it already geographically. So if you say you just want to have it for Europe, for example. And then the data is available either in GRIP, which is a format mainly used to share data between meteorological organizations, and it's very standardized, and it has a long history of sharing data, which is good. But it's if you're not coming from a meteorological background, it's not so easy to understand the GRIP format. So that's why the data is also available in NetCDF. Who is familiar with NetCDF data? Okay, also quite a few. Okay. Then there's the terms of use. So it's open data. You just have to agree on the Copernicus license. And then you see here 2 buttons. So here it shows show API request. And this request basically can be copy and pasted into a Python environment, and then you can download the data you're interested in. So this is, I show you just in a bit how you can then programmatically do it. Or actually I do it now. So basically, this is just a help for you that you can easily browse data you're interested in, and then you can just copy paste it. You go to your Python, your Python environment, and then okay, maybe I should go over how it works, how you can set it up basically. Okay, so we come back there. Good. So this is the climate data, and then there is, as I said, there are 2 services. Another service is the atmosphere monitoring service, and they also set up specifically for the atmospheric data or air quality data, a atmosphere data store. It has the same principle, just it offers data on air pollution, on greenhouse gases, on climate forcings, etc. And so if you go to atmosphere, how does this? Okay, this is a broken link. Up. If you go to atmosphere, so ads.atmosphere.copernicus.eu. I think I have to open it. So I have to make it bigger for each. So it has the same interface, and you can also browse here through data sets. And there is, for example, also a reanalysis data set for air quality. So CAMS is like the abbreviation for the atmosphere monitoring service. There's reanalysis data, there's solar radiation information, and there's also air quality forecasts for Europe available. And it has the same interface, so you can browse through the information you're interested in, like nitrogen dioxide, carbon monoxide, particulate matter, etc. And then on the bottom, you also have a API request, which you can then get the data. Okay, we come back there as well. So what we saw later, so the only difference of the atmosphere monitoring service is that there is no toolbox yet. So you can't You don't have this interactive editor similar to Google Earth Engine, where you can load the data directly in the editor and then develop some applications. Good. Yeah, what I said, like go there, have a browse through the data. There's climate data stores, climate reanalysis data, seasonal forecasts, fire indices, river discharge information. On the atmosphere is global reanalysis, global and regional analysis and forecast data, the global fire and assimilation system, the GFAS data, which provides fire information, and greenhouse gas fluxes. There's in future, all the data from the atmosphere monitoring service will be available on the atmosphere data store. For now, there is a subset of data available, but it will evolve in the future. So the question is, okay, how can we now retrieve data? So how can we interact and work with these data systems, specifically if you not only want to download one layer or one variable. There is an API, it's for Python, CDS API, it's a Python library, and you can install the CDS or the library. Before, you have to self-register at the interface. So if you go here, I'm logged in here, but I think I can also log out. Let's see. So yeah, you can here log in or register, and you can create an account. So once you're registered, you have to log in to the web portal, and then you can go to the API how-to page. And okay, let's do it. So I just log in here again. Okay, and then so once you installed the library, you can go to this page, API how-to page. It explains you again the. Oh wait, doesn't it? Okay, there's it seems to be a bug, but let's see if it works. So basically, because usually when you're logged in, then you should see here like a specific key and token which has been developed for you, or which has been here. Now we see it. So basically, once you're logged in, you can go to this page, and then you can copy paste this information. You can copy paste it here, and now we can already use our magic command with. I think it has to be for write file, because we want to in the home directory, we want to write a file.cds API RC, and we want to add this information to this file. And so, because I did it before, it's overwriting, but if you did it, or if you do it, it should be new. It would be actually interesting to know if you have to do it for yourself, or if you actually, if I provide you the Jupyter Hub and you're working on my image, if you can actually use already my credential. This would be quite interesting. If someone wants to do it and let me know, this would be very helpful. And we can install the CDS API on the Jupyter Hub. We already installed it. And then we can import it. And this is now here basically an example. So this is an example. So we can easily copy paste the example we had here from one of the data sets, for example, where we went to have, yeah, let's go here, for example. And so basically here, the information, so this is not very useful here because I didn't select anything, but so the API request, which is shown here, we can copy paste it into this cell here. This example retrieves now one time step on 1st of January 2019, 2-meter air temperature variable from ERA 5 reanalysis data in the format netcdf, because on default, you would get a grep file. So you have to specify the key format that you want to get netcdf. And also natively, the ERA 5 data is on a 0 to 360 grid. So if you want to have it on a grid running from minus 180 to 180 longitudes, then we also have to specify the area key here. And then we can say, yes, we want to download the data. And so we packed it into a function. So in Python, so if it's too fast for anyone, please let me know. I can also explain more the syntax of Python. There's not a problem. So in Python, you define functions just with def and then your function name. Here we don't have any variable or parameter we want to give the function. We just want to execute the code, our retrieve request here. And then we can execute it. Yeah, so executing a cell, you can either do it here, just click the button and you run it, or you can also use shift and enter. This might be much more convenient. Okay, so now this, it's incomplete. Okay, let's see, maybe we don't need, probably we don't need this one. Let's try it again. That's always the danger of live sessions. Okay, so now this works. So it informs you a bit what the retrieve is doing. They welcome you, they send a request, and because we now downloaded a very small data set, because it's just for the purpose of showing it today, it was quite fast downloading the data. And if we now go back to our overview here, we see here that there is a download netcdf file available. So now we have netcdf files. In Python, there are different libraries you can use to open the files. One very popular library for the recent years is xarray, specifically for large volumes of modeled and organized data. Xarray became, I think, probably now the standard. It is also very easy to handle netcdf data. There's also other libraries like netcdf4, for example. It's also quite easy to load netcdf data. And if you use script, there's even for xarray a driver or a Python interface that supports grep together with xarray. I just show you here a small example on how to import xarray, how to open a netcdf file with xarray. So we import the library, import xarray as xr. And then xarray has the function open_dataset, and you can just provide netcdf, so the path to the netcdf file, and then the data is directly loaded. And this is here the structure of an xarray dataset. So it gives you the dimensions of your data. xarray is also very powerful in handling multiple dimensions, not only up to 3, but even up to 5 or even more. So it's very powerful in this way. It also shows you what coordinates our data has. So here we see the longitude and latitude and time information. Also that our longitude information is now shifted to a minus 180 to 180 degree grid. We see the data variables, and so xarray or also netcdf, they can actually hold multiple variables. And so this is example that we have just 2 meter air temperature, but we could also retrieve 10 different variables, and then our xarray data set would have 10 different variables. Just to go back to the command, in case we want to actually load more than one variable, we just specify here a list. So a list in Python, you just specify with square brackets. And let's say not only 2 meter air temperature, but we're also interested in total precipitation. Then we can specify here different variables. The same also works for year, for month, and for day, and also for time steps. So if you want to have more time steps, more variables, you just specify a list with your information you want to download. Now, because I promised, if I know there is a R package available, so because we really have to make efforts to also bring not only the Earth observation and climate community together, but also the Python and the R community. So it's not only restricted to Python users. Con Hufkens and Reto Stauffer, they released a package ECMWFR. It's now very mature. I also I follow it on GitHub, and I have the impression it's commonly used also from our users. So you also have a programming interface to actually retrieve the data within R, and it has the same structure. So you also have to provide this retrieval request, which we have here. It's just that you work in an R environment.
Can you use the same suggestion that is automatically generated by the GUI of the website?
Say it again, sorry.
So, like, before you got like a suggestion how you would programmatically get Python code, you get Python code for the API.
Yeah.
You don't get that for the R.
No, so on the website you don't get it. Oh yeah. The suggestion is for Python, but there's the retrieve request here. So this is not very useful here. So let's just make a more meaningful example. So let's go to era 5. We click some information just to have some more. Yeah, I can actually also showcase this one. Then we are not in 2 years, in 2 months, and time. And so basically, if we now go to the show API request, so you work with, so the example is for Python, but what you will need for the R package is this retrieve command. And so basically, instead of importing CDS API, you then just load your ECMWFR package, and you just use the retrieve command you put together basically. And this is here, it is showcase also the example here that now we chose 2 different variables, and then the API request shows you already the list of variables you want, also the same for year and for months. Okay, so far so good. Yes?
And some clarification. In one Jupyter notebook, can we both use R and Python? And then in the same notebook, like for design is Python syntax, but the next line is R syntax.
Yes, it is possible. There is this package I said, Py2R, which is actually like an interface between 2 programming languages, and it's supposed to work that you basically, for each cell, you specify what programming language the cell shall support. So you can specify, okay, this cell is supposed to be Python, and then you can write your Python code, and then the next cell is supposed to be R. I was saying before that I tried to set up a small example, and maybe if I'm successful, then if I'm in one of the evening sessions, then we could go over, it's called Polyglot Programming, that you basically not in one environment anymore, but you bring that bring two different programming languages together. And also the important thing is that you can actually also use one object you created from Python, and then you can load it in R. And so if I'm successful to develop one meaningful example, then I will make an announcement and we can see it in one of the evening session the next day. There's anything, any other questions? I see there's a question. Shall I also check on Zoom? Oh, they don't. They don't see the demonstration. Okay.
Well, you share the screen, so I know.
To everyone online, I'm sorry if it was then very abstract. So shall I wait, or what do you think? Or it works actually also online?
Did you share your whole desktop, or you share it on one screen? It works fine now, they say.
Ah, okay. Okay, perfect. Good. Okay, good. So yes, it's also on. Yeah. So, okay, good. All right. Okay, so if there are no questions, then I would go to the next data access system. So it's WEkEO. Who heard of WEkEO before? No one? Okay. Okay, good. Then I try to shed a bit of light into the dark, because you probably, in future, if you want to access Copernicus data, you will hear a lot of WEkEO. So in the entire Copernicus sphere at the moment, we have now very nice and a lot of open data available. But at the same time, it's so much data that we have to, or we are forced to implement and set up new data access systems because we just can't download it anymore. Is it big enough? Otherwise, I can also make it a bit bigger. But this should be fine, yeah. So WEkEO is a DIAS. Is it better like this? Yeah. WEkEO is a DIAS system. It's an abbreviation for Data and Information Access Service, and it's basically a cloud computing environment or cloud computing service to access and process Copernicus data. It's still work in progress. The first stable release has been at the beginning of this year. But it will just mature the next years, and it will become one of the services if you want to, at least if you want to have access, and at the same time if you want to access and process Copernicus data, then this will be one of the system. So as I said, Copernicus has 6 different services, and WEkEO offers so far data from 4 different services. So from the services land, marine, atmosphere, and climate. And you can already access different type of sentinels, so Sentinel-1, Sentinel-2, Sentinel-3, Sentinel-5P. Let's just open the web page. So basically, the idea, of course, is in the long term that we don't download data anymore, but we have a hosted processing machine in the cloud, and we can directly access the data there, and we can run our analysis and our experiments, and then we don't have to download large volumes of data. So you can have a look here. So if we go, for example, to data, an interface opens oh, this is actually already my example. Okay, good. Basically, so if you go here and you click on the plus sign, you get a catalog of the type of data that is available. Shall I make it bigger again? Maybe a bit. That's probably better. And so, yeah, you already see, so you can browse by service. So let's see, for example, for climate data. Oh, there's again our ERA 5 data. So you can get ERA 5 data. You can also get seasonal forecast data, but not only for climate. Let's go for marine services, for example. There is, yeah, data from the marine service, yeah, like global ocean data, global surface chlorophyll, etc. So let's go back here. We can also browse by Sentinel. So if you're only interested in Sentinel 5P data, for example, we can, so it offers so far data from Tropomi. We can get information, and there we get information on the data, and also the temporal extent, the spatial extent as well. We can add it to the map so that we can already see how the data looks like. Here you get then the different type of variables that are available. So nitrogen dioxide, I already set up the example, but we can, for example, also get, let's get carbon monoxide, for example, and we can add it to the map. Oh, but it's still loading. Okay, so if it's finished loading, then actually we it will show you a layer of Sentinel 5P carbon monoxide and also nitrogen dioxide. So let's go back to our information. It also gives here a dataset ID, and this ID we will need later on, because this is one ID, which is important if you want to retrieve data. Good, now let's go back. Are there questions so far? Okay, good. So we covered this one. So the question, how to retrieve data, it's with WEkEO is basically, actually I can also show you an example here. Can I show you? Okay, I log in quickly, and then I can show you also how WEkEO looks like if you want to use the, now you get my, okay. Okay, now I'm logged in. I go, so this is the data, so you can browse the data, you can see what is available. Let's go back. Okay, now I'm signed out again. Okay. Good. So if I go to wekeo.eu and then I sign in, or if you do it, then you will come to this interface, and there is a button, go to my dashboard. And so if you go there, you get your profile, and then there is like, yeah, so there's, and this is the interface where you can manage your profile, but also your cloud processing tenants and virtual machines, and you can also access directly the data from a Jupyter Hub environment on WEkEO. And so if you go here, so let's open the Jupyter Hub on WEkEO. It might take a while. Okay, maybe we let it load and then I just continue. Okay, now here. So there's, of course, there is also to try it. You don't have to be afraid that once you once you log in, that you already have to pay something. There is, of course, a free version which allows you to try out things, and then you can also go to a paid version if you think it will be useful for you. So let's go just to a small server option. Okay, so we let it load and we come back there. So how to access data? So as I said, you can download data from WEkEO as well as an interface, or you can directly load the data on WEkEO into a virtual machine. And then you can also use Jupyter notebooks in order to communicate to your virtual machine and to process data. The way how you access data, it's called Harmonized Data Access, Hda API. And it's a REST-based single protocol that allows you to subset and download data sets from WEkEO. There is a step-by-step, or this tutorial here, it's a step-by-step guide on how you can search and download data with the Hda API. And I will just come back on it. We will make use of some functions which are stored in a separate notebook. But I will show you how you can work with these functions. So it requires 6 steps in total. So first of all, which we kind of already did. So we searched for data sets on WEkEO. We are aware of the ID, of our data set ID. Yeah, so the next step is then to get a data set collection ID. Then we have to get a WEkEO API key based on your registration credentials, password and username. Then we can initialize the WEkEO Hda API. We can load a data descriptive file, or we can also have just a data request, and then we can download the data. Just to go back, has it started now? Okay, so now I'm here on JupyterHub on WEkEO. So if you see here, I just make it bigger. It loaded now. Now it's a bit too big, probably. So basically, this is just this is similar than the JupyterHub environment we're in. So you have this interface. You can browse. I'm actually in one folder here, but there are some notebooks already provided. You can browse what is available, but this will be much more mature in the next month. So there will be also examples provided for if you want to get started, and some example notebooks. But basically, yes, once you understand how Jupyter notebooks work, we can also just start our own notebook, which is based on Python 3, and we can load a new one, and then we can actually get started. So, and this is basically the examples we showcase now on our JupyterHub. You can also easily just do on WEkEO, retrieve data, and then once you have the data, then you can work with the data on WEkEO. You can just, because if you can just have better processing environment in case your local machine is not powerful enough. Good. So the first step in Python is always also to load some libraries. So you load a library with import and then the library name. So we just execute this one. And now we come here to load our helper functions. And so if we go to our interface here, you see a notebook. It's called Hda Api Functions. And we can open it. This has actually like all the functions which are used in order to retrieve data with the Hda API. And so, yeah, let's go to one function. So basically, it's just a notebook full of functions. As I said before, you define a function with def. Here, for example, it's the example to generate our API key, where the function takes the username and the password, and then it returns a base 64 encoded API key, which you need to authenticate to WEkEO. And a good thing is that basically this helps you also to modularize with Jupyter Notebook, so that you don't have everything in one notebook, which might sometimes also disturb your workflow. You can really also outsource your functions and then recall it in a notebook, in a different notebook. And how you do it is you use the library IPyNB. You can here, so with this library, we call or we load the entire notebook Hda_API_functions, and we import all libraries from this notebook. So if we execute it, and I open a new thing, and for example, I want to have now, or it works now, we can go through it. But a good thing is also, so in case I don't know what a specific function is doing. So if we go, okay, now I have to zoom. Okay, good. So let's say, okay, we haven't seen this notebook, and let's say the workflow shows us that the function generate API key is used, but we don't actually know what this function is doing. Then we can use the question mark and enter the function generate API key, and we execute. And then the doc string is opened for this function. So if the function is documented with a doc string, then you see here the description of the function, what the function is doing and what it also returns. And this is quite useful to outsource functions in notebooks. So we just...
What is this code Python or IPYND?
Yes. It's a package, yes. Yeah. No. Probably I loaded it before in some other notebook, but apparently it works like this. But to be honest, I don't know quite, but I can check. But it's a package, yes. It's, I don't know what FS and full means. I have to go to the documentation, but yeah, this is, yeah, I can look it up. So exactly, so this one is basically the command, and then here, this is the name of your notebook, yeah, which yeah, I think it has to be in the same folder than your notebook, and then it can read it.
Julia, a question. So, people follow your lectures, they could participate in the special prediction competition game, right? Because they get, two estimated from Sentinel-5.
Yes.
But they will have to download the whole world if they want to overlay or something. That's too complicated. Could we get just the values of the points?
Of points, Sentinel-5P points. To be honest, on WEkEO, I'm also not sure, because this is always the big question. So either you tailor a system for for large volumes of data, and then you have global data, but then time retrieval is a bit difficult. With WEkEO, I'm not sure if you can retrieve just point information, like time series information, but you could certainly just narrow it down to a very small region, and then yeah, you don't have to download so much data, and then you can still take the time series out for one specific point.
You could download point by point.
I'm not sure if it allows you that you only specify, so I think you have to specify a small area of interest, so it has to be a 4 corners area. Yeah, but it can be like, I don't know, 1 times 1 or 2 times 2, yes.
Can you please switch the video again? Let's try the
Okay.
the video and then switch to the other one. Yeah, still not okay. Let's switch back to
Yeah, it's not optimal. Sorry. Yeah.
Yeah,
Okay.
sorry also about it. Some we tested yesterday.
It's the nature of life events. Okay. Are there any questions so far? Yes?
I have 2 questions. One is that for the WEkEO thing, I see that you generate the password and the username. Do you have to log in online?
Yes. So basically, you go to, so if I sign out, you go to WEkEO, WEkEO.eu, and then you can sign in here. And if you don't have, so you can also.
So once you have an official username and password.
Exactly. Yeah, exactly. Yeah, yes.
And the other question I had is there a download limit that function?
Sorry, say it again.
Is there a limit on how many titles you can download from Copernicus?
To be honest, I don't know that there is certainly a limit, so you can't just, I guess, you can't just, I don't know, fire up 100 parallel requests and retrieve the data, so they probably will limit it somehow, but I don't know the exact numbers, yeah. So far, so good? Okay, good, then we go to Hda API. Example. So yes, we were already on this interface. So here we can browse for data sets, we can search for data sets, and we get more information. And as I already said before, if we go to documentation, we get the data set ID which we need, and we can already, so let's say we're interested in Sentinel-5P tropomi data. We got the data set ID, and now we define it here as a variable data set ID, and we execute it. The next step is now get the WEkEO API key. I'm quite happy that I remembered to delete my username and password, because this also happens quite often. So, but I pre-generated already. So basically, the function generate API key takes your username and password, which you can specify here. So I can add my username and my password, and if you then let run the function, then what you get back is a, I think, base64 encoded API key, basically. And my API key is this one. So in this API key, so we have to store it. So and then so we store it. This is the API key. And then the next step is to initialize the Hda API request. And in order to initialize it, we first specify a download directory path. So in our example, we just want to, because it's an example, it's just in the home directory, we specify it. And with the dataset ID, we just specified our API key, which we just generated, and the download directory path. We can load the init function, which basically initiates a dictionary with all the information which the harmonized data access needs in order to retrieve the data. And so if we specify it, and let's just open and see what is in Hda in this dictionary. And so here you already see that this dictionary, it creates already a link to the broker endpoint where the data is. Then it checks if we accepted the terms and conditions. It gives access token address. So all the information that the WEkEO understands, okay, we followed the guidelines in order that we are ready to go and download data. Then we, once we initialized and we communicated basically that we want to get some data, we have to request an access token, and this access token is then also stored in the Hda dictionary. So the dictionary is basically our, let's say, our documentation of requests. So it holds all the information WEkEO needs in order to retrieve the data we're interested in. So if we load, or if we use the function get access token, and we just provide the dictionary, we just initiate it, and we return also the dictionary again, then we see, okay, we have now an access token which is valid for 1 hour, and this access token here, which is printed, if we now print again our dictionary, we should see the access token here. So there is an entry in the dictionary with the access token. And so as part of this Hda API process, we basically just develop our dictionary, which then uses all the information to download data. The next term, so in my case, probably it's already, so we also have to accept the terms and conditions. So it's open data, so we can use it, but we have to agree on the licenses, on the license. In my case, because I already accepted it, so it also stores the information. But probably in your case, once you do it the first time, then it just tells you that, yeah, it was successfully accepted. Good. Then the next step is that we load a data descriptive file, and then we can request the data. And so the Harmonized Data Access API, the data information we interested in, it's stored in a JSON file. And so the API understands JSON, and all the information of our data we want, so the collection ID, the temporal subset, also the time period, has to be in a JSON format. And yeah, so we can for example, define specific keys in the JSON, so dataset ID, the date range, the bounding box values, also a string choice value, so what type of data, should it be offline or near real time or non-time critical, etc. So on the Jupyter Hub, we also have an example of a JSON file, how it looks like. And so I just open the file. So if you go back to the overview of the Jupyter Hub, you have here a file called s5p_data_descriptor.json. And this is basically, yeah, it's big enough, yeah. So it's basically a JSON where, what I already said, where we specify the information. So here, I think I created a bounding box for Europe, or at least, yeah, around Europe. The dataset ID is Sentinel-5P. The data range, because it's an example, we're interested in 1 day, 8th of April, for example, for 1 hour. And then we say we don't want level 1, but level 2 data, for example. And so all the information of your data you store in this JSON encoded file. And if you have this file, you can easily just open it with the JSON.load function. So here, what this cell is doing, it's saying, okay, we want to open this JSON file as our object F. And then with the function JSON.load, we want to load our object. And then we can see how our object looks like. And if we execute it, then basically the information we just saw in the JSON file is now in the data object here. And alternatively, so you don't have to store it in a JSON file, it's probably convenient for if you want to reproduce some data requests, or if you want to use the data request multiple times, then it's probably easier to outsource it. But alternatively, you can also just define it in a cell here and specify the data object. And then we have, so now we have our data file, and now we have to initiate a request to assign, yes? Yeah. Yeah. Exactly, yes. No, this token, no. So let's go back here. So this is, so basically you have a token which was here, I think. So this token is basically a saying that or communicating to Wiki, okay, now you want to request something. The API key, you really have to you have to have a, so the API key is based on your username and password. And so if you enter here your username and your password, and then you let run the function generate API key, then you get here your base 64 encoded API key. And with this API key, so we initiate the library, the dictionary. But it is really based on your username and password. Exactly, yes. So the API token we actually have here. So this is an access token.
Maybe I can enter it manually here.
The access token, yes, you can. Yes, you can also specify. So if you don't want to get the access token programmatically and you have it on WEkEO on the website, you can also specify a separate key. It's called then access token, and then you can specify your token which you have on the website. Yeah. Any other questions? How are we? Are we already lost, or it's good to follow still? Yeah. Okay. It's long sessions, but yeah. Let me know if something is too fast. Okay, good. So we're almost there. It's already a good sign. So yes, we specified our data request in a JSON file, and the next step is to initiate this request. And for this, we can use the function getJobID, because this basically assigns a job ID to our request now. And so we can, this is the same again here. So we extend our dictionary with the job IDs WEkEO provides us for our request. So if we execute it, so we give here the dictionary we already developed, and we enter here our data object we saved or restored. We see that so now the query was successfully submitted. We have a job ID, and the status is now completed. And basically our dictionary now holds the job ID, which is used by WEkEO to run the job. And then with this job ID, we can then run the function getResultsList, which creates basically a list of data files available for our data, for the data period we specified, and also the geographical bounding box. And again here, the result list we also want to store in the dictionary. And so we see here now, so it's running, and we see, because I specified it, because it's just an example, I specify it just for half an hour on 8th of April. And we see that for this time period, there are exactly two IDs available. So it tells us, yes, total items 2. And we see here of the information, so the file name. So Sentinel-5P data also stores the time period of the file, and it's around 11:34. And the other one is around 11:39. And so there are 2 items now. And so the next, and then one step before we download data is to create an order ID. So based on these files we specified, we want to download, we now create an order ID, and with this order ID, we can then download data. And so we can use the function getOrderIDs, and again here we store the order IDs in our dictionary. Oops, yeah, okay. So now we have, for our 2 data sets we want to retrieve, we have order IDs, and status is completed. And basically, if we just check here again, the Hda API dictionary is basically that now it's much longer than at the beginning, because we stored quite a few additional information along the way. So we have the dataset ID, we have the API key, we have the access token, we have our job ID, we have the results which are valid for our chosen period and data type, and very important, we also have the order ID here. And with this information, we can basically use the function download data we give the Hda Dictionary, and WEkEO understands, okay, I have to now transfer the order IDs and to download the data, and we can do it. And yeah, now, oh wow, this is quite fast today. Okay, yeah, and the data will now download basically. Okay, there's one. So one data is downloaded, and there's one other problem I have to investigate. But now we see there should be one Sentinel-5P data here. Yes, and you see here that we now have one Sentinel-5P file. Are there any questions to WEkEO?
The cost of WEkEO, what is your experience?
My experience is none. I don't have paid for WEkEO yet, but we can go there. There are different T-shirt sizes. There's price. So if you go to wekeo.eu, you go to pricing.
Did I mention like 66 month?
And then it's basically you have to, so you get virtual machines, processing tools, free networking, support, and I think here you also see the different T-shirt sizes. So depending on what size you want, you can have bigger or smaller RAM, block storage, file storage, load balancers, GPUs, etc. And the prices. So the prices are per year. So if it's per year and per month is then in brackets. I can also make it a bit bigger.
The upper one is per month, and then the lower one is per year, and then it's again per month.
It's okay. Probably what I understand. So if you go on a monthly flat rate, then you pay more than if you already sign up for a yearly.
So
and then if yearly, then it comes down that you only pay half of actually the normal monthly fee.
24,000 euros a year per month, so with the 16 CPUs, that's expensive. You can buy 3 of these.
I think any feedback is highly welcome, because they want that WEkEO is used, and I think it's So I think for this specifically, this feedback is very good, because it's also should be for smaller. It should be also accessible for smaller companies or universities and researchers.
Do they have a list of users at the moment? Do they have some roadmap of users?
So at the moment they about to start. So because the public release of the first version 1.0 was just in March or April. And so they have also a YouTube channel, and they just started a series of training events where they provide like some small tutorials on what is WEkEO, so it's something what we actually did today. So like that you have a JupyterHub interface, that you can access data with the Hda API access to understand it a bit more. And so they have now basic training, and it will be also a bit more advanced in the future.
Okay.
Yeah. Okay, good. So if there's no other question, then we go to the next. So we continue. So I just wanted to say that basically I give you an overview of the data services. It's not that I have any preference. So basically, I think it's also helpful always to know where data is available. And the idea here is that I provide you some examples, and then you can choose yourself what system might be of interest for you. So the next one is the AWS Open Data Registry. Who has heard about it here? Okay, only one. Okay, so yeah, because when I heard about it, I think 2 or 3 years ago, I thought, oh wow, this is great. So basically, it's also Amazon Web Services. AWS is cloud computing from Amazon. And it has a strong focus on geospatial data sets. So you really see that they have an entire open data registry with geospatial data. So and it will just, I think, grow more in the future. So there is definitely a sector where you can benefit to use AWS with geospatial data. There is this registry, what I said, on open data on AWS. Okay, hang on. This should work. If you go there, you see like, there's 69 data sets at the moment, or I think even more. On different Sentinel data, so Sentinel-2, Landsat 8, also Earth ERA 5 data is available, Sentinel-3 data. So it's quite powerful because there's also 2 options again. So if you work on a cloud-based processing environment with AWS, then you already have a S3 storage bucket with the data, which you can just load in your virtual machine on AWS, or you can also use one of the Python libraries or APIs to actually download data from the storage space there. And in the example today, I will show you an example how you can actually retrieve Sentinel-5P data from AWS, how it works. And actually the examples I developed, this case study on COVID-19 actually makes use of the Sentinel-5P data I retrieved from Amazon Web Services. And there is, you can have a look yourself. There's a variety of geospatial data from, of course, others satellite data as well, but including Sentinel-1, 2, 3, and 5, and also ECMWF ERA 5 climate reanalysis. Just also to check out, AWS also has a Earth on AWS program. And this is basically a program specifically they interested in building large-scale applications based on open geospatial data. So if you work as a researcher or you need processing data and you have an idea how to make use of the data that is available on the Open Data Registry, there is also, you can also apply for cloud credits for your research project. So it could be of interest for some here. Okay, how to retrieve data. There is Python SDK for Python. It's called Bo2.3, and this allows you to access data on AWS S3 storage bucket. So S3 is the short name for a storage bucket on the cloud of AWS. And so below, basically, I showcase a small example how the Bo2.3 library can be used in order to download Sentinel-5P data. So we start again with importing libraries, so Bo2.3 and Bo2 Core with import. And then the first step is to initiate the Bo2.3 client with the function Bo2.3.client, and then we define the bucket of interest. The bucket of interest, let's go back and see how this is actually structured. So let's open the example for Sentinel-5P data. And so this is how it looks like. And you see, yeah, a description of the files. You see here already that, because this is also the reason why I downloaded here, that the level 2 data is already aggregated on a daily level. So instead of different data each day, it's already aggregated on a daily level, which is quite helpful. And basically, yes, we just have to find the, where's the bucket name here? Hang on. This is the resource name. Yeah, you get, okay. So basically, yeah, so here on Boto 3, let's go back here again. So we specify the bucket name, which in cases is MIO minus S5P, and you can see it here, but not specifically specified, I think. So probably, yeah, you have to see here. So yeah, so you just have to take off basically the here the things before, and then you just see here the name of the bucket, which is MIO minus S5P. You have different levels. So you have near real time or non-time critical information, offline data, but it's all in one bucket in different folders. Okay, good. So basically, we initiate our client. We say that it's we're interested on a storage S3 client, and this is just a standard procedure to configure your client. And we also specify our bucket we're interested in and we can execute the cell. Good. The next step is then to create a Packinator and iterate over the results from the API request. And so Packinators are features of Boto 3 that act as an abstraction over the process of iterating over an entire result set of a truncated API operation. So it's something specifically of Boto 3. You first basically have to define or create a Packinator, and based on this Packinator, you can then call the function Packinate in order to iterate over the different listings under this of the API request we have. We can do this. So the first step is here, we create our Packinator. We use for this our client we just defined, and then we use the function getPackinator. And with from the Packinator object, we then call the function Packinate. We specify our bucket and also a delimiter in order to understand the folder structure. And if we go then, and if we have a look to how results looks like, it doesn't help us a lot because the Packinator object is just a page iterator. And so in order to see the whole structure of the data that is organized on this on the S3 bucket, we have to iterate over the object. And so we can do this with the following command. So we basically iterate over our results Packinator object, and we look for common prefixes in order to get the folder structure. And if we do this, we see that, yes, we have different levels of data available. And the next step is that, yes, so let's say in our case, we're interested on offline data, and then the daily aggregated level 3 data already. And so instead of the delimiter keyword, which we used here, so we just used a slash. We can actually also use already a more detailed information that we directly get to the data we're interested in. And so we use the prefix that we interested in. in cloud optimized geotiffs, online or offline, and then the level 3 daily aggregated NO2 data. So we use this prefix and then we packinate again over our page iterator. It's here the same, so it's not very useful, but we can actually iterate over this object in order to see what data is actually available. And so we can do this to iterate over the contents of each page of the page iterator. And since the resulting object is a dictionary, we get a much cleaner output when we just select the dictionary key. So if we select here, so we go over our pages which we defined. This is the page iterator, and for each object in the page of our page iterator, we want to actually retrieve the key of the dictionary. And so if we go over it, we get a list of the files that is available. And so you see here that so I can actually show you the difference between here. So if we don't specify directly the dictionary key, but we just specify each entry of each entry that is listed in the contents, then we see here that it's actually each entry is a small dictionary. Is it actually seeable? Yes. So it's a dictionary. So we have the key information, which is actually the data, the file name. We also see when it was last modified, also the size, etc. But this can be, so this is quite messy, and it's not so easy to actually see what different type of data. You also see, for example, that yes, there are like for each day there are several entries, but then you actually thought, okay, there's only daily data, so why do we have several entries? And so this is the reason why if we already print just the key information from the dictionary, then we get a much cleaner output. And so we get here this cleaner output, and now, for example, we see that for each date, so for example, for 28th of July, we have actually 3 or 4 different entries, and we have the normal, just the general unprocessed raw data, but then we also have mask data where like cloud information is already flagged out for quite conservative, where a mask filter of 75% was applied, or a bit less conservative, where a mask filter of 50% was already applied. So this is basically, so this is already a processing step which you would actually need to do for Sentinel-5P data. And here, because it's already aggregated on a daily level, you can already get the data on a daily level. It is already it's already, clouds are already, or non-valid pixel were already removed. And basically, yeah, and then you can start actually using the data rather than doing, extensive processing steps before doing any analysis. Good. So basically now we have our list of files that is available. So we see here, so if we want to check the length of the selected files, oh, now I changed, okay, this is not, don't want to have markdown. So if we, why is this not selected files? What did I do now here? Okay, so hang on, I do it again. And okay, so now we have, so basically here we, because yeah, as an example, we are just interested in the data which used like a very conservative cloud filter. So we here filter all the data which end with mask 75_4326. And so basically, from all the data that is available, we just get the data which we're interested in, and we store it in an object called selected files. And so if we just print it, we see that for each day we have now, so yeah, 5th of March, 6th of March, 7th of March, we have now one daily file. And so if we just see how many files are actually valid, we see that we have 163 files for 163 days. And so as an example, we just want to download one example. So let's say we want to get 161. So this is for 6th of August this year. And if we want to download it, we can here specify it for our list of files on file names we have. We can first print it to make sure that to understand what data is actually called. Then we split it by the name, because in the end we just want to take the name here and not the entire path of this S3. And then with our client, which we defined at the beginning, and the function download underscore file, from the bucket of interest, also the file name, and we can actually download it directly. So here we just download one example, and it's actually, yeah, so it's always good to see. So here, this is, I forgot to mention, so on this circle here, so if you execute a cell and the cell is actively executing, then it is filled out. And so once the cell finished, then it is transparent. So there is always also a good check to see if the cell is still running. And so if we now go back to our overview, we should have another Sentinel-5P data here, and it's a masked data set with 75% cloud filter. Okay, are there questions to AWS Open Data Registry?
Yeah, this AWS, have you tried putting some of your data there?
The company I work with, MIO, they edit the Sentinel-5P and also Sentinel-3 data there. So how it works is that they have a specific, so and also the ERA 5 data, it's actually companies who upload the data there and set up a S3 bucket.
I'm just asking if you say your categories.
I can ask my colleague and can give you feedback, or can let you know offline.
We can still spend the time for questions. Please, questions. Yes.
Considering that you get the Sentinel WEkEO and through AWS, is there a difference? Would you recommend one over the other?
No, that's why I said, like, it really depends on you. At the moment, the fact is, at the moment, AWS is just much more mature than WEkEO. So yeah, it's just, the idea of this lecture is to provide you different pathways, and it's your choice then what you use. On the difference between WEkEO and Sentinel-5P on AWS is that on AWS, it's already pre-processed data, so it's on level 3, so it's cloud optimized geotiffs, which are daily aggregates. So depending what you want to do, you can save some processing steps which you would need when you retrieve data from WEkEO.
And neither of them are actually the original source. They're both scraping from ESA.
No, the original source is from ESA and Copernicus, So it was not ESA who uploaded data on AWS. It is so, and how Open Data Registry works is there are always third-party providers who provide the data. WEkEO is basically, it's also not, ESA is not involved. It's EUMETSAT and ECMWF and Mercator Ocean, but it's the Copernicus sphere. So it's still, it's from Copernicus, the data is provided there, yeah.
So in terms of updating speed from the satellite's images, which one is actually more quicker, more directly?
There could, so probably WEkEO, because there's the, so probably you have, once the data is generated, it will also be available on WEkEO. AWS, because there is always a dependency on a third-party provider, there could be sometimes delays. So what we see, so here now it's 6th of August, I think the last entry was, or 7th of August. But because there is a delay, because basically the third-party provider also has to retrieve the data once it is available, they have to process it, and there's always a bit of a delay, but I think so far they're quite good in maintaining the updates. And I think, I don't know exactly, but probably once they go, or once they upload the data as part of this Open Data Registry, there, Amazon, there's an agreement with Amazon and the third-party provider to make sure that the data is maintained.